In this video, we are going to look at some examples of rational equations, applications of rational equations. Okay, so first one, it's proportion. It's a proportion with variables involved. So to solve this first equation, we're going to go ahead and do cross multiplication. There are two danger numbers, not allowed numbers in this case, that will cause domain restriction. Those numbers are x cannot equal -2 and x cannot equal -6. Those are the two numbers. -2 and -6 are not allowed numbers in this case. So let's go ahead and do cross multiplication, and we'll have to do foiling when we cross multiply. X minus 2 times x plus 2. So leaves me with x squared plus 6x minus 3x minus 18 equals x squared minus 4. Now, to make my life a bit easier, I can go ahead and cancel out x squared from both sides. 6x plus 3x is 3x. I'm sorry, 6x minus 3x is 3x. Minus 18 is -4. 3x equals 18 minus 4. 3x equals 14 and x equals 14 over 3. And it's not one of the restricted numbers, so it's okay to go ahead and box and circle and say this is my solution. Let's look at example number 2 now. So 3x plus 2 times 9 equals 12 times 5. Let's go ahead and distribute here. That's 27x plus 18 equals 60. 27x is 60, take away 18. 27x is 48. X comes out to be 48 divided by 27. And we can divide both 48 and 27 with 3, and that is 16 over 9. All right, next example, example number 3. Again, we're going to be doing cross multiplication and then foiling. 3x plus 1 times 2x minus 7 equals 6x plus 5 times x minus 4. Let's go ahead and foil. That's going to give me 6x squared minus 21x plus 2x minus 7 equals 6x squared minus 24x plus 5x minus 20. Let's go ahead and cancel. 6x squared is gone from both sides. So I'm left with negative 19x minus 7 equals negative 19x minus 20. That doesn't look very nice, so I can go ahead and add 19x to both sides, and that will leave me with -7 equals -20, which is not possible. So that means in this case there's no solution to this equation. There's no solution because we ended up with a statement that is not true. The left side is not true. Left side is not equal to right side, so not possible. So that means there's no solution to this equation, which means doesn't matter which x values you input in, the two sides of the equation are never going to be equal. Here's next example. The ratio of weight of an object on Earth to weight of the same object on Pluto is 100 to 3. Okay, so 100 is the weight on Earth, 3 is the weight on Pluto. Keep that in mind. On the top I'm writing Earth, on the bottom I'm writing Pluto. We'll have to stick with that on the other side of the fraction as well. If an elephant weighs 4,100 pounds on Earth, find its weight on Pluto. So 4,100 pounds on Earth, and I'm just going to assume, let's say the elephant weighs x pounds on Pluto. Okay, that's my assumption, so I'm going to figure that x on Pluto. All right, so let's go ahead and cross multiply. 100x equals 4,100 times 3. X is 4,100 times 3 divided by 100. 41 times 3 is 123 pounds. So the elephant will weigh 123 pounds on Pluto. Next kind of application we're going to look at, these are called the work applications of rational functions. Work applications of rational functions. In these kind of problems, we'll be talking about 2 or 3 or more people. So we'll be talking about, think about if I take 5 minutes to clean the whiteboard, what part of the board is cleaned after 1 minute? It would be 1/5. What part of the board will be cleaned after 2 minutes? So that'd be 2/5. What part of the board will be cleaned after 3 minutes will be 3/5 and 4/5, and after 5 minutes 5/5 will be done, which is one. That means one whole job will be done. Okay, so we'll have one full job in all these problems. And we'll always make a table for these work applications. The first column will be the name, so you're going to be given maybe person 1, person 2, and together. Second column will be time taken, and the third column will be very important. It's always going to be same for every single work application. Amount of work done per unit time. The unit time in each case can be different. Unit time can be per hour. The unit time can be days. Unit time can be months. Unit time can be years. Unit time can be minutes. So it depends from problem to problem. So here's first example. Suppose it takes Kevin 35 minutes to shovel the driveway and sidewalk, and it takes his brother Jordan 50 minutes. Okay, so we have Kevin and Jordan, and the unit of time in this case looks like it's minutes. Okay. Kevin takes 35 minutes, Jordan takes 50 minutes. And how long will it take them to do the shoveling if they work together? Okay, so if they work together, how long would it take them? Well, if you're thinking that if they work together, it would take them 85 minutes, that is not correct. Because if they're working together, we cannot add their time. Because individually, if one person can do it in 35 minutes, two people should be able to do it in faster than 35 minutes, right? Because he's getting help. So if Kevin takes 35 minutes to complete the whole job, he does what part of the job is completed in 1 minute? He completes 1/35 of the job in 1 minute. Jordan completes 1/50 of the job in 1 minute. So we don't know how long do they take together. We can say together they take X minutes to complete. Together they take X minutes, because when we don't know something is missing, we can always call it the variable X. Together they take X minute. So they will be completing 1/X part of the job in 1 minute. Now here's where we will get our equation from, the last column. Okay, so Kevin's rate plus Jordan's rate is going to be equal to together rate. Okay, now this is a rational equation. To solve this, I'm going to multiply both sides with the LCD. LCD for 35 and 50 is 2 times 5 times 5 times 7. There's a 7 as well here, and which is 350. 350x. Remember, the LCD has to involve every single denominator. LCD of 30, 35, and 50, and x would be 350x. Let's go ahead and distribute and see where we get from here. 1/35 times 350x would be 10x. 1/50 times 350, that would be 7x. Okay, we don't want that long x. 7x, and then 1/x times 350x would be 350. So 17x is 350. X comes out to be 350 divided by 17. 350 divided by 17 is going to be 20.58. So together it would take them 20.58 minutes to complete the job. So write the complete sentence answer at the end. Kevin and Jordan will take 20.58. You can use more decimal places. If you round to 2, it would be 20.59. 20.59 minutes is what they will take if they work together. Okay. An underwater tunnel is being built using boring machine that begin at opposite sides of the tunnels. One machine can complete the tunnel in 18 months. A faster machine can complete the tunnel in 9 months. If the machines start at the opposite ends and work at the same time, in how many months will the tunnel be finished? Okay, so there's my machine 1, there's machine 2, and then they are together. The machine 1 takes 18 months, and the machine 1 will be doing 1/18 of the work in per month. The unit of the time in this case is a month. Second machine takes 9 months, and it would be doing 1/9 of the work per month. And we don't know how long do they take together, so we can say, let's assume both machines finish the work when they're working together, finish the job in X months. Okay, in X months. We don't know how long they would take. We would just assume that they take X months together. So together they will be doing 1/x of the job per month. Now this last part is where we will get our equation from. Okay, machine 1's rate plus machine 2's rate equals 1 over x. Now the LCD here, we're going to solve this rational equation. LCD will be 18x. So I'm going to distribute both sides 18x, and I'll be left with x plus 2x equals 18. 3x equals 18, and that leaves me with x equals 6. So 6 months is what it would take if both machines are working at the same time. Okay. Another example of a work application here, an experienced carpenter can panel a room 3 times faster than an apprentice can. Working together, they can panel the room in 6 hours. How long would it take each person to complete the job? Okay, so now we're going to think about, okay, experienced carpenter finishes the work 3 times faster. So we got to be clever here. If experienced person takes X minutes, apprentice, the new person takes 3 times more time than that, right? New person takes 3 times more, 3x. If new person takes 1 hour, the new person takes, if experienced person takes 1 hour, new person takes 3 hours. If experienced person takes 10 hours, new person takes 30 hours, okay? That's what this sentence means. Experienced carpenter can panel the room 3 times faster than the apprentice. And we don't know how long each of them take, so I'm just going to assume that experienced person takes X hours, because the unit of time would be hour here in this case. Experienced person takes X hours. The new person, apprentice, would take 3x hours, 3 times more, 3 times X, okay, 3x hours. And together we know that they can complete the job in 6 hours. So the rate at which experienced person work is 1 over x. The rate at which apprentice works is 1 over 6. And the together rate is 1 over 6. So that's where my equation comes from. 1 over x plus 1 over 3x equals 1 over 6. What's going to be my LCD in this case? The LCD will be 6x, and I'm going to go ahead and distribute 6x to everything on both sides of the equation. 1 over x times 6x will be 6 plus 2 equals x. So x equals 8 hours. That means the experienced person, how long would it take each person? So experienced person will take 8 hours, and the apprentice, how long will apprentice take? Apprentice will take 8 times 3, which is 24 hours, because we already know. Why am I saying 8 times 3? Because I'm using the value of x, plugging the value of x into the time apprentice takes. 3 times 8 is 24 hours. Okay. Here's another example. This one is another application of rational equations. These are called the distance, rate, time applications. Okay. So remember the word DIRT, D-I-R-T. It's distance equals rate into time. Always start by making a table, and in the table we're gonna have a column of D for distance, R for rate, T for time. In this problem, we're talking about the speed of current. Okay, speed of a boat in still water is 29 miles per hour. If the boat travels 140 miles downstream in the same amount of time that it takes the boat to travel 92 miles upstream, find the speed of the stream. So we don't know speed of the water, speed of the current, or speed of the stream, but we do know anytime the boat is going downstream, it's going to cover the distance faster, because the speed of water is helping the boat go faster. Speed of water is going to help the speed of boat and speed of water will be added when it's going downstream. Okay, so keep that in mind. And when it's going upstream, the boat speed will be reduced. The actual speed will be reduced than what it is on the speedometer, because the water is working against it, and it's going to be friction causing to slow down that speed. So upstream, the speed rate would be 29 minus x. Let's talk about the distance. How much distance does it cover? Downstream, it covers 140 miles. And how much distance does it cover upstream? It covers 92 miles upstream. Now, we don't know anything about the time, but we do know that same amount of time. Both the times are equal. So what are we going to do here? In this table, I just see d is equal to r into t. Distance is equal to rate into time. We don't know much about the time here, so we want to express from here. I can say time is distance divided by rate. We can use this relationship. Distance divided by rate will be the time. So distance divided by rate will be the time here. Distance divided by rate will be the time here. We also know that these two times are equal to each other. So the time going upwards and the time going downwards are downstream. Upstream and downstream are both equal. So let's set these timers equal to each other. 92 over 29 minus x equals 140 over 29 plus x. Okay, to solve this, we're going to be doing cross multiplication. So 92 times 29 plus x equals 140 times 29 minus x. 92 times 29 is 2668 plus 92x equals 140 times 29 is 4060 minus 140x. Now my goal is to bring x's on one side, so I'm going to add 140x to both sides. 140 plus 92 is 232x equals 4060 minus 2668. Okay, 4060 minus 2668, that is 1392. 232x is 1392. 1392 divided by 232 is going to give me 6. So x is 6. That means the speed of stream is 6. And what are the units? Miles per hour. And that's what's given in the problem. So speed of stream is 6 miles per hour. And next example. After riding at a steady speed of 40 miles, a bicyclist had a flat tire and walked 5 miles to a repair shop. So he's doing some walking and some riding. The cycling rate was 4 times faster than the walking rate. Okay, cycling, riding, walking. So he did ride his bike for 40 miles. And how much did he walk? He walked 5. So I'm writing these under the distance column. Okay, now let's talk about the rate. The cycling rate was 4 times faster than the walking rate. We don't know the cycling rate, we don't know the walking rate, but we do know that the cycling rate is 4 times faster than the walking rate. When you have two things missing, it's always good to call the smaller one as x. Okay, let's say walking rate is x miles per hour. Walking rate per hour. So let's say the walking rate was x miles per hour. The cycling rate is 4 times faster than the walking rate. So 4 times faster would be 4x. Okay. And the time spent cycling and walking together. So they're telling me the time together time, not the time for cycling, not the time for walking, but they're telling me together time. So what can we do to write the equation here? Again, remember, we did say distance is equal to rate into time. My time column is empty over here. So to isolate the time, I can say time is equal to distance over rate. So distance is 5, rate is x. That would be the time for walking. Distance is 40, rate is 4x. That would be time for riding. And this is where my equation is. The last column is the one that gives me my rational equation. So the walking rate plus the cycling rate is equal to 5. I'm going to try to simplify this a little. 5 over x plus 10 over x equals 5. My LCD in this case is x. That turns out to be 5 plus 10 equals 5x. I'm going to distribute everything on both sides, this x into the entire equation. 15 equals 5x, 3 equals x. So from here I can tell that the walking rate would be 3 miles per hour. Walking rate is 3 miles per hour. And riding rate, that's 4 times 3, that would be 12 miles per hour. Okay, 3 miles per hour and 12 miles per hour. Next equation, 1/4 equals the quotient of a number and 8. Find the number. Okay, 1/4 equals the quotient of a number and 8. All right, find the number. So we're going to go ahead and cross multiply on both sides. 4x equals 8. X comes out to be 8 divided by 4, which is 2. If twice of a number added to 3 is divided by number plus 1, twice of the number added to 3 is divided by the number plus 1. We don't know what the number is, so we're calling it x. The result is 3/2. Find the number. So I'm going to go ahead and cross multiply. 2 times 2x plus 3 equals 3 times x plus 1. 4x plus 6 equals 3x plus 3. 4x minus 3x is x. And we can subtract 6 from both sides. X equals -3. So -3 is that number. Let me double check if that's correct. 4x plus 6 equals 3x plus 3. When we subtract, that's a positive x. 3 minus, yeah, that is correct. So the number is -3. Next example, 2 hikers are 11 miles apart. This is again distance rate time problem. They meet in 2 hours. Find the rate of each hiker if one walks 1.1 miles faster than the other. Okay, so distance rate time, we have hiker 1, hiker 2, and together. Okay. Now here, they're going towards each other. Keep in mind, the 2 hikers are walking towards each other. The total distance between them is 11 miles, okay? And as they're walking towards each other, the distance is decreasing. They're not both going to cover 5.5 miles and 5.5 miles because they're not walking at the same rate. So if you're thinking that, oh, each covers 5.5 miles, no, that's not right because they don't walk at the same rate. One person is walking faster than the other. We don't know which one is walking faster. So we can say, let's say the slower hiker walks at x miles per hour. The faster hiker would walk x plus 1.1. X plus 1.1. Okay, my page is moving a little. So x plus 1.1. Okay. And for how long have they been walking? Well, each of them have been walking for 2 hours because they meet after 2 hours. They both have been walking for 2 hours. Now let's go back to the relationship d is equal to r times t. Now my distance column is kind of empty, but I can use the other 2 columns to fill up my distance column. So r times t, d will be 2x here, 2 times x plus 1.1 here. All right, that's where my equation is when I have all 3 here. So distance covered by first hiker plus distance covered by second hiker is equal to 11 miles. Let us go ahead and distribute. So 2x plus 2.2 equals 11. 4x plus 2.2 equals 11. We would subtract 2.2 from both sides. 11 minus 2.2 is going to be 8.8. So 4x equals 8.8. X equals 8.8 divided by 4, which turns out to be 2.2. Okay, so that means hiker 1 walks at 2.2 miles per hour. hiker 1 walks at and hiker number 2 3.3 miles per hour. How do I know the hiker 2 walks at 3.3 miles per hour? Because I'm plugging the value of x into the hiker 2's rate, which is x plus 1.1. So this came because I did 2.2 plus 1.1. 2.2 plus 1.1. That's how I could figure out the second hiker's rate. Okay, another example. Suppose 2 trains leave Holbrook, Arizona, at the same time traveling in opposite directions. Okay, the 2 trains are going in opposite directions. One train travels 10 miles per hour faster than the other. In 3.5 hours, the trains are 322 miles apart. Okay, so for how long the trains have been going? Each of the train has been going for 3.5 hours. We don't know which train is walking slower, which train is walking faster. So I'm going to say this train is walking at a rate of x miles per hour. The other one is walking at a rate of x plus 10 miles per hour. And do we know anything about the distance? Well, we know the total distance between them is 322 miles after 3.5 hours. So they are 322 miles apart after 3.5 hours. So let's complete the table. We don't have much in the distance column here, but we know distance is rate times a time. So I'm going to go ahead and do rate times a time, which is 3.5 times x. And 3.5 times, here I'm going to have to use parentheses, x plus 10. All right, this is the column where I have my equation here. So I'm going to write this equation, and this is my 3.5x plus 3.5 times x plus 10 equals 322. Okay, distributive property here. So 3.5x plus 3.5x plus 3.5 times 10 is 35. That 5 doesn't look good. 35 equals 322. 7x plus 35 is 322. 7x is 322 minus 35. 322 minus 35 is 287. 7x is 287. And 287 divided by 7 is 41. X turns out to be 41. So we can say we wanted to find out the speed of each train. So we can say speed of train number 1 is 41 miles per hour. Speed of train number 2, we were given in the problem that the other train goes 10 miles faster, so 51 miles per hour. And that's all in the applications of rational equations.